Alright guys, emergency video. Teach you guys some math today about means and hypothesis testing. I told you guys I'd talk about whatever you guys wanted me to talk about. Two people told me that they want a video especially on this is a real life math homework question that I had in my Stats 2500 class at college level. This is a real life college math homework question. The United States ranks 9th in the world in per capita chocolate consumption. Forbes reports that the average American eats 9.5 pounds of chocolate annually. Suppose you are curious whether the chocolate consumption is higher in Hershey, Pennsylvania, the location of the Hershey's company's corporate headquarters. A sample of 38 individuals from the Hershey area showed a sample mean annual consumption of 10.05 pounds and a standard deviation of 1.5 pounds. Using alpha of 0.05, do the sample results support the conclusion that the mean annual consumption of chocolate is higher in Hershey than it is throughout the United States? So, this is a multi-part assignment. Part A saying state the null alternative hypothesis. So, the alternative hypothesis makes it really easy to start off with because the alternative is what we are looking for. We are looking for if Hershey consumption is higher than it is throughout the US. That's our last sentence here, right? So the key word that we are looking for is higher, right? That's what gives it away. So we are looking for our mu is greater than 9.5. Is Hershey chocolate consumption higher than the rest of the US? That's our alternative hypothesis. Now our null hypothesis would say the opposite. So that's why I like to start off with the alternative, because then the null is the opposite by default. And you have three options to choose from. So for the alternative hypothesis, you can either say it's greater than, less than, or not equals to. So in this case, it's higher. Higher means greater than, and we're done. For our null hypothesis, you have three options again. You have equal, greater than or equal to, less than or equal to, or equals to. In this case, because our mu is higher than 9.5, that means our mu is less than or equal to 9.5 because it's the opposite. Now find the value of our test statistic. That means we are going to open our spreadsheet. There's a link down in the description. And we're going to fill out our information of our x bar, our mean, standard deviation, n, which is our sample size, and our alpha. So our x bar is what we were looking for in Hershey. So that's 10.05. Our mean will always be in the hypothesis. That's our 9.5. Our standard deviation was given right here, 1.5 pounds. Sample size, sample of 38 individuals. That means 38. And our alpha was also another given, which is 0.05. So I already had our formulas built in because I already did this for homework a couple weeks ago. So our test statistic, that formula is given to us right here. What does that mean? That means our x bar minus the mean divided by the standard deviation over the square root of our sample size. So in this case, that is 10.05 minus 9.5 divided by 1.5 over the square root of 38, which is equal to 2.260285134, right? I think in our question it says round to 3 decimals. So we are going round B7. I don't know why I clicked B6. It says round to 3 decimals. Round B7 to 3 decimals. 2.26. Is that the right answer? It is. Now for our p-value, this is what's going to determine if we're going to reject or not reject our null hypothesis. I'm going to start this one from scratch. So the mean falls into a t-distribution. So we're going to put equals t dot, and then we're going to have 3 options to choose from. So I'm going to put t dot dist actually. And we have 3 options to choose from. We got t dot dist, which is our left tail. T dot dist dot 2t is our 2 tail. T dot dist dot rt is our right tail, our upper tail. And how do you know which one to use? So if you go look at our alternative hypothesis, our relationship symbol is going to reveal which formula we're going to use. Our relationship symbol, the point where it meets, is don't point in the direction. That's how I remember it. It's sort of a silly way, but it helps me. So since our mu is greater than, the arrow points to our right, which means this is going to be a right-tailed test. If 9.5 was greater than our mu, our arrow would point to the left tail, meaning it's a left-tailed test. And 2-tail test is not equals to. So if this was mu is not equal to 9.5, that is when we use our 2-tail test. But in our case, it's mu is greater than, our point is pointing to the right, so it's a right tail test, an upper tail test. I keep doing that. So t dot dis dot rt, because it points to the right, we're going to put in our test statistic with our degrees of freedom, which is our sample size -1 and -1. That's the second time I clicked B6. I'm sorry, guys. Problem asks us to round to 4 decimal places, 1.49, 1.49, and then our conclusion. What are we going to do? Are we going to reject or are we not going to reject? For our upper tail tests, we are going to reject if our p-value is equal to or less than alpha. And what was our alpha? Our alpha was 0.05. Our p-value was 0.0149. Our p-value is less than alpha. So we are going to reject it. We can conclude that the mean annual consumption of chocolate in Hershey is greater than the mean annual consumption of chocolate throughout the US. So that is our conclusion. And with that, that concludes this entire math problem. Thanks for watching. Remember to like and subscribe. If you found this video helpful, I ask that you share it with a friend. More views, more people we can help. Super cool. So thanks for watching. I'll see you guys in the next vlog. Peace.